This is the third video in a three-part series and will cover, at a non-confidential level, the approach that Medici Technologies has developed for accurate non-invasive glucose measurement. If we re-examine the tissue characteristics of the individuals used in the photo analogy, significant differences are observed in terms of skin thickness and melanin, collagen, and water concentrations. Skin thickness, collagen, and water have a direct impact on the scattering and absorbance characteristics of the tissue. A more detailed examination of subjects 12 and 2 showed these differences. Subject 12 has a thicker dermis, more water, and more collagen than subject 2. These characteristics will result in a shorter optical path length through the tissue. Here, you can see these relationships in a more quantitative manner. Each object in the figure is a subject observed over a 1-month period. Typically, an individual occupies a moderately defined space with some variance, while the different individuals measured are clearly discrete. These differences between people and over time cause path length distribution differences that result in errors in the Beer's law calculations. These path changes are the dominant error in non-invasive glucose measurement. If you assume that Beer's law is appropriate, then a standard multivariate regression model can be developed, much like was done for the serum or blood samples mentioned in the prior video. But if such an approach is utilized, the results are lackluster. Medici has subject data from a non-invasive glucose measurement study on 40 female subjects over the course of 20 visits, with 2 measurements obtained during each visit, resulting in approximately 1,600 samples. If these data are assembled and a conventional regression model developed using partial least squares, the results are very poor. The glucose measurement performance of the data is in stark contrast to the blood results presented previously. Consider the differences in these 2 measurements. The interstitial fluid surrounding the tissue is similar in complexity to serum, so the inflation and error seen in tissue measurements must be due to the matrix in which the serum exists. As you can see, the scanning electron micrograph of skin shows the matrix to be a very sponge-like structure. Using our prior eyeglass prescription analogy, the prescription or measurement method works for some people, but not for everyone. This observation makes intuitive sense, as tissue differences are very apparent between people, young versus old, thin skin versus thick skin. In retrospect, there is no fundamental reason why a highly complex medium like tissue would satisfy the simplifying assumptions of Beer's law. At this point, it should be clear why glucose is hard to measure, so now the focus changes to the Medici solution, and the departure Medici has made from conventional approaches. Returning to our eyeglass analogy, how can we successfully characterize the tissue so an effective measurement methodology can be developed? Recent developments in handwriting and speech recognition, population segmentation of advertising, and even song recognition have significant applicability to this problem. Each of these classification problems is extraordinarily complex, but all have been advancing in the past 10 years. In all cases, the main problem has been effective extrication of the key features for recognition purposes. For example, in handwriting recognition, the size of the character is a dominant feature, but doesn't contain any information regarding the determination of the letter written. In speech recognition, the speed of the dialogue and the volume contain little information regarding the words actually spoken. So any effective classification method must focus on the relevant features while being insensitive or immune to those more dominant but unimportant features. The same holds true for non-invasive glucose measurement. The challenge in developing such a classification system is to determine what characteristics are important, extract these characteristics, and then assemble this information into a recognition system. A good visual example of this process can be seen by examining the work done by Fujitsu in regards to Mandarin handwriting recognition. Their system uses a multi-layer feature extraction process. The first processing layer recognizes simple features, while the second processing layer recognizes more complex features. The features that are most useful in identifying characters are automatically extracted through the system of layers, and data for each corresponding feature is accumulated for each character. In the area of advertising and purchase recommendations, companies such as Google, Netflix, Amazon, and Target have been very successful. These systems employ statistical techniques to identify sets of users, known as neighbors, that have similar purchasing habits. These companies have segmented their consumer population based on purchasing preferences. Medici's approach is to conduct population segmentation for the purposes of glucose monitoring. Medici has studied the approaches used for similar problems and combined elements of many of these approaches for the purpose of glucose monitoring. The approach that is most similar to Medici's is the Music Genome Project, developed by Pandora Radio, to identify songs with similar characteristics. In the Music Genome Project, each song is represented by a vector, where each element, or gene, in the vector corresponds to a characteristic of the music. A gene could be the gender of the lead vocalist, or the prevalent use of groove, or the level of distortion on the electric guitar, or even the type of background vocals. Each gene is assigned a number, which then combine to create the vector that describes the song in a numerical format. When a user picks a song, Pandora's matching algorithm constructs a list of other similar songs based on the selected song's vector. The ubiquitous use of Pandora Radio speaks to the success of the method. The success of the Music Genome Project is based on two critical elements. One, the effective identification of key music characterization variables, and 2, the vector matching algorithm. If further information on the music selection method is desired, the listener is encouraged to read this patent on the method. Essentially, the method is an innovative approach for successfully clustering songs that have similar characteristics from a listener's perspective. For the purpose of non-invasive glucose measurement, the goal is to identify individuals, or to cluster individuals, that have similar tissue characteristics from a glucose measurement perspective. As mentioned before, Medici has combined concepts from handwriting, speech, and song recognition, as well as population segmentation techniques, to create an effective method for resolving our problem. In a more scientifically rigorous fashion, Medici seeks to identify individuals that have the same tissue characteristics from a path-length distribution perspective. Over the past 3 years, Medici has pursued many approaches and encountered numerous dead ends. However, Medici has persevered and now has a feature extraction method that effectively clusters individuals with similar tissue characteristics. This system creates a vector of information, much like the music genome approach. The resulting vector, or template, can then be matched to other samples to create a cluster of like tissue characteristics. The ability to identify similar tissue types for a glucose measurement perspective now removes the dominant error source in non-invasive glucose measurements. These tissue classification methods have demonstrated feasibility both on simulated and real subject datasets. A detailed report on these results is available. In summary, Medici Technologies possesses a deep understanding of the existing measurement error, searched the scientific literature for ideas on resolution, synthesized ideas from multiple disciplines, and created an effective solution. Medici looks forward to further validation of the method in a larger clinical trial and eventual commercialization of the approach.